Hello, everyone, and welcome to another webinar about Zephyr. So this time is gonna be a little bit special because we're gonna make an exercise. This is pretty much going to be all about making your own drivers. So drivers in Zephyr is very special topics. It's something that you eventually are going to need to develop for your own projects. When you download the upstream of Zephyr and you start working with them, you will notice that the project also includes a lot of drivers, especially to control the peripherals, starting with the most common ones like GPIOs, UART, SPI, I2C, and along, etc. It also includes a lot of drivers for external modules like accelerometers, gyroscopes, even LEDs, something so simple as a single LEDs, and as complex as, for instance, GPRS modem and stuff like that, graphic displays, and long, etc. But even though with all these drivers included, it is pretty much impossible to include drivers for literally every device out there in the market. So there's going to be at a certain point that you're going to need to create your own drivers. So writing your own drivers in Zephyr is it could be sometimes a challenge. It depends on the peripherals that you are intended to control. But Zephyr has a very good specification about how you must write your own drivers. We are going to speak only about binding files. It's going to be the first thing that you need to understand in order to start creating your own drive. So once again, let's jump right direct into the code because we are software engineers and we really understand and we really like writing code. So let me share the screen. Just give me a second. Let me select the right monitor. And you should starting to see my Visual Studio Code in about a second. And you can see right here at my Visual Studio Code that I have an empty project. This is the most simple one structure that has a main.c file with a simple main functions, an app overlay where we're gonna write or we want to describe in our DTC the hardware that we are using. So for this occasion, what we're gonna do is to create a very well. In this series of webinar, we're gonna make a simple driver to control LEDs. Okay, it's the most simple one, but that's the whole idea, to start with something simple that you can use as a reference to start making things more complicated, right? So let's begin. Let's make the assumption that we have an LED connected to one of our pins in our microcontrollers. Which microcontrollers? But it really doesn't matter. So let's assume, and in here we're going to declare a node that we're going to give the name of my LED, all right? So which is going to have only one property, which is called GPIOs. This property will be assigned to a fundle array, meaning that is an array composed by a fundle. Remember that a fundle or pointer handler or whatever you want to call it in DTC is basically a reference to another node. In this case, a node that is describing our port C in our microcontrollers. The second value is actually the pin, and the third value is also numeric value that is basically a flag telling you that this pin is going to be active with a high level. We're going to save it and we're going to proceed. So instead of writing the code manually, what we're going to use is to copy paste from my snippets in order to avoid potential typos that I can have. All right. So this is pretty simple. All right. So we are including the GPIO drivers, and what we're doing into here is getting a structure using this macro called GPIO underscore DT underscore spec underscore get. So accept two parameters. All right. The first one is a node ID with the name my LED, and the second one is the property from that node that we are going to get. In this case, we only have one and it has this name. That's why you are seeing the second parameter namely. All right, so you've been working with Zephyr in the past, or you are starting to working with Zephyr in the past. You will notice this is one of the most simple examples that you can actually build. All right. So what we're going to try to do is to build this very simple example when we are configuring one single pin as an output, and we toggle its value every second. So let's see what's going on. Let's see what happened. All right. So when we try to build a program, we're gonna notice something. We're gonna notice the build just fails. All right. So Wes is complaining about, I don't know about this. I don't know about this property. Not declared. I mean, I don't know what you mean, right? So why is that? So let's go back to our DTC and to our node. So what actually we're noticing right here, if we've been doing this in the past, we notice that we are lacking from a property that's called compatible. So, but what's compatible? Compatible is actually, it's telling this node needs to use a binding file, right? But first things first, what is a binding file? So binding file, basically, it's like a complement for the device tree. So a binding file is actually a file in YAML format. What it's telling you about the properties that a nodes will have. It's pretty much like telling DTC and Wes, you know, while this node that you are seeing right here, the properties that includes shall be interpreted in this following way. All right. So we need to indicate something. You know, by default, you can use some binding files that count with Zephyr by default. No, the most common ones is the GPIOS keys, right? This is the one that you usually use, or you want to use. Sorry, that you want to use when you are actually using LEDs on your microcontroller. But let's make the assumption that it doesn't exist something like that. You know, so we need to make it from scratch. We need to create some scratch. We're gonna give it a name. And we're gonna call it simple LEDs, right? So what we're doing here is we're telling you, hey, you're gonna look for a property called compatibles, and you're gonna look for the name simple, comma, LEDs. All right. So what Zephyr is going to do is going to look at the default Zephyr installed in the Zephyr directory. So in my case is under the directory depths, under Zephyr directory, BTS, bindings, and then inside binding there is a collection of binding files that corresponds to a given driver for a given peripheral, internal or external. We can see things like, for instance, the CAM peripheral, internal clock, counters, CPU, crypto, DAC, external displays, you name it. All right. There's already ones for LED, by the way. You can go right here and you can see a bunch of YAML files. So this is the default directory where Zephyr is going to look. But again, we're going to assume there's not such a driver like to control the LEDs. You want to make our own. But we are not going to put it in the Zephyr directory because this driver is only specific for our application, right? So what we're going to do is to replicate the directory that you already see, but in the root folder of our project. What we're going to do is to create a new folder, call it yes, right? So inside the folder, we need to create a new one that is called, for sure, bindings. All right. We are just following the same structure that we just watched right here that comes with the Zephyr source code, right? So we're just replicating. Okay. So inside this, we're going to create a new file and we're going to use the same name that we place on the property compatibles in our DTC overlay. Simple LEDs but with the extension YAML. So the comma is actually part of the name, okay? It's not, it doesn't represent something. Well, it does. Actually, there is a convention, right? The convention says the first you need to put the name of the manufacturer, all right? And after the comma, you have to put the name of the device. Let's say, for an instance, that you are making a driver, a binding file for a external memory app. And the manufacturing, the company that manufacturing the EEPROM is Microchip. So you have to put right here Microchip, comma, and the model of the EEPROM memory, all right? In our case, we're just playing around, all right? Just making an example. So that's for that reason, we are using only simple. I'm sorry, I made a mistake here. Let me rename. Simple LEDs, and that's it. All right. So what we're gonna put right here is the following code. Remember, it's in a YAML format. YAML is a description language. Okay. So basically, you have something like a tupla, where this is the property that we're gonna use, and this is the value of the property. In this case, the first thing that we need to add is a description. So we want to write a description about what this binding file is going to do, right? In our case, let's connect it to a pin for multipurpose, whenever you want it. No? Second property is compatible, right? And there is an stream value that suspiciously has the same name of our file, all right? I'm gonna leave it like that for the moment. And then we're gonna start with the properties. We're gonna start naming the properties. I'm gonna say, I'm going to have a property called GPIOS, right? And this property is going to have the type of a Fendel array, all right? It's like giving a type to a variable in C. This floats, is int, is chart, you name it, okay? And line number 8 is we're going to say if it's required or not, if it's mandatory to be declared in the node, or is optional. No, every time that you put this value to true, it shall be mandatory. If that property doesn't exist in the node, it's going to throw you an error. All right. And finally, you can provide an also description. The descriptions will be for you at the time that you're reading this binding file. This is going to work just like documentation. It's going to provide a feedback to you in order to know what's going on with this property, what it's going to do. All right. So let's save the file. Now let's try to build again from scratch. So we cross our fingers and let's see if there is any errors in the build, and everything goes accordingly. So there's no error. So we can finally build our software. So what happened is we're telling you, hey, this node is gonna use a binding file called simple. It's where you're gonna find the meaning of the properties that you're gonna see right here. So when the DTC entered, remember the build process in Zephyr is before the compilation steps. It's the DTC runs. For what is going to do the DTC compiler is basically to parse these files, also the binding files, and it's going to translate to a certain values. Well, those values are basically defined that later on the driver is going to use. That's something that we already mentioned on previous webinars. If you are kind of curious, let's go back to a previous webinar and check it out. What I mean, it's basically generate a header file. All right. So, okay, let's do not waste time on that. Right. So I'm not gonna run the program. So I'm gonna limit myself to build. So everything is built. So in theory, if I flash these programs, we are going to see the LEDs starting to blink every second. Right. With this macro, we're extracting the property GPIOs, which basically are these values for pin and flags, and that's what the driver is going to use in this specific functions. So we're not making a new driver right here. We're just limited to write a binding file. It is important because sometimes you don't have an LED connected to a pin. Maybe you have a MOSFET that is connected to a pin. So you are not going to use, for instance, binding files that describes or speaks about LEDs. Maybe you have to create a new ones that it tells you that what you want to control is a simple MOSFET. Okay. All right. So let's continue. There's an important thing is the property that you are declaring right here. In the case of the GPIOs is already specified in Zephyr. No? At the moment that you write the GPIOs, the West already knows that you basically are speaking about, you need to do is to replace by an underscore. Okay, so in order to avoid these kind of problems. So when the DTC compiles our overlay file, basically it's going to replace this name for a name that's using an underscore. So that's why we need to use an underscore right here. So we update the name of the property. So what we're going to do is we're going to try to build again. Let's not start from scratch to make it faster. And voila, there's no error. All right. So the name is going to be accepted by Wes only if it ended up with GPIOs, with the GPIOs, of course. You can use as many letters as you want, as any other names that you like, but it will mandatory to place the name, to end the name of the property with the word GPIOs, right? So let's go back to a binding file and let's find out this name over here. So what I'm going to do is a little test right here. So I'm going to change the name. Simple it. I'm going to change it and put it right here. So one of the things that you may be starting to wonder is this compatible property refers to the name of the file. So maybe it's like that, right? Let me build. We just changed the name. We didn't change the line number 3, the value of the compatible property. And we're just seeing that nothing happens. No error happens. So we can conclude the name of the file, it's not, or basically, it's not what we are writing right here. So then what happened? Let's go back to the original name, right? Let's go back to this property. Let's change the name. Let's make a variation on the name. And let's try again, but this time let's try to build from scratch, yeah? And let's see what happened. All right, there is an error. There is basically, we're watching the previous error than before, than when we didn't have this property in our notes, right? So we just changed the name of this value. Let's go back to the previous name. Let's build again from scratch. And let's conclude something, all right? This is the value that this property is looking for in this node. It's not the name of the file, right? It's the value that you are actually writing right here. So well, usually you're gonna use the same. You're gonna use the same. You will want to name in the same way the name of the file and the property compatible. You know, maybe there are some exceptions, but that's the common thing that you're gonna find out. But what I wanted to clarify, what I wanted to clarify is basically this: the value that you print right here, these strings, it represents the value that you are using, that you are assigning to compatible, not the name of the file. Right? This is very, very, very important. in order to avoid mistakes. So now that you have this binding file describing your nodes, which you can actually declare more nodes of the same kind using the same binding file. Okay, we just declared two LEDs, and on our main file, we're gonna put the code for both LEDs that we are using, right? But my LED 0 and my LED 0 here. LED 1, my LED 1 is being using right here. I'm extracting in both the property LED underscores GPIOs, which is the one or the only one that I have declared right here. Let's build again. Why not? Just to verify everything is correct. This is my code. And in this way, we can see that we can continue declaring. If we have more LEDs connected to our microcontrollers, we can continue declaring in the same specific way. So like you already had experience with Zephyr, no? So the first driver that you've been using is GPIOs, and the first probably the same the first binding file that you've been using is the GPIO LEDs. And you will remember that to declare these LEDs, you have to use child nodes, okay? A new node that is part of the parent node, right? This is another way to declare your nodes. Okay, we didn't change the values. Okay, it's connected to the same pins, etc. We keep the same names, and what we're trying to use is to use our same binding file. So let's try to build again from scratch. Let's see what happened. It fails. Okay, all right. It's telling you that this LED on the dash GPIO is marked as required in properties, but it cannot see it. It's not there. For that, is not there. Okay, wait a minute. But it's right here in the properties. I'm telling you to use this binding file, and I'm telling you that this property is called LED dash GPIOs. So then what is telling me is not working? Why? Okay, so you're specifying in the DTC that this node has two different child nodes, all right? But you're not doing the same in the binding files. In the binding files, you are not specifying that child nodes will exist. In order to do that, you need to use child binding property. Okay? Now you're specifying that this property belongs to a child, not to the parent node. Okay? You would try, build again. Probably we're gonna see this is going to work. Yeah, it is working. All right? It is working. Because, so what it's telling me this is the binding file is not only telling you about properties. Okay? It's telling you about the structure of the node that you are using. In this case, it's telling you there's gonna be child nodes. And those child nodes are going to have these properties, all right? So at the moment that you're declaring the nodes, you will know that the pins where the LEDs will be connected shall be placed into child nodes and not directly into the parent nodes. Which is the right way, which is the correct way, is up to you to decide. This will depend on how your driver is going to work. Okay, this is a very good way to make, like for instance, groups, a group of LEDs or a group of buttons or a group of pins that control MOSFETs, gateways, or I don't know, right? Anything. So let's continue. Now that we know about child nodes, let's continue with the properties, all right? we only have one properties. How many we could have? Well, as many as you like. And for instance, let's continue with another one. Let's just for fun call it label. This is going to be, well, let's take advantage of ChatGPT. Type string is not going to be required if it just specified here that the required value is false. It's pretty much equivalent to no writing at all. Right? It's the same thing. Okay. So let's go for another property. Let's suppose that we are going to use delay as part of our driver, and the property will be an integer of type integer. So we're going to use a number instead of a string or of an array, and in the same way as the label property is not going to be mandatory. So that's why we are not writing require with a value of true. So we are not writing at all. So I'm going to save my file. And what I'm going to do is to assign these properties, new properties, to only one node, all right? Label that we already said that the kind of value is going to be a string, all right? And the second one is going to be a string, an integer. If you want to express an integer, it has to be surrounded by these symbols. You cannot assign an integer value only with numbers. It has to be surrounded by this symbol, just like the array, just like the bundle array, or just like any other kind of array, right? So we're going to save it. And what we're going to do is, once again, we're going to build it. This time, I don't think I needed to build from scratch. And I had an error. Maybe there is a typo right here. All right, this is good. Delaying properties. Okay, I'll have some node type integer. So, okay, my bad. Just to trust on artificial intelligence. So just don't do that. The right type is int. But it's good to have errors. So we're building again, and voila, we have these properties. That, by the way, these new properties are not being used by our main code. You can see we are not using it. The only one that we're using is the let_GPIOs. And one node has the properties declared, and the other node hasn't, all right? Because we specified in our binding file that those are optionals, are not required at all. So let's make another one. Let's make another property just for fun and just to show you that these properties could have any name that you want. I'm going to use my name because why not? All right. So what kind of type? Well, I'm using the type integer and a description. I'm going to place right here that is just for fun, right? Because why not? I'm going to assign this new property to the other LED, an integer, 200, and that's it. I'm just come up with this property out of the blue. It has my name, it has an integer value, it is optional, and let's see if Wes can build our program with this property called Diego, because why not? All right. So wait a minute. So we're putting these new properties, but we are not using it. What about if we want to use it? Okay. So all right. Let's access to property Diego, and we know that this property is an integer. So we are going to declare a variable of type int, and we're gonna use a name And instead of assigning a random value, I'm gonna get the value from the DTC. And for that, I'm going to use a special macro that is called DT underscore prop. So I need to specify from which node you want to extract that property. And I'm gonna use property node node label, the node label. What's the name of the node that has the property? Let's go back to the TTC, and we can see is my LED 0, right? So it's my LED 0. Names do not accept capital letters, so I'll change it the letter L, and then I'm sorry, it's not right here. You're going to specify which property you want to extract from that node. It's our crappy property called Diego, right? That's it. And then I had a value that it's just an integer that we can use to represent the delay. So I'm going to put it right here, right? I'm going to build my program to see what's going on, if it's working or not. And voila, it's just working. You see, I invented a property in my binding file. I use it in one of my nodes, and I also extract it from the DTC and use it on my actual C program, on my actual C code. All right. So this is really important. This is something that we need to understand in order to start developing our own driver. So it is quite important to notice that the properties are declared on the binding files. Those properties is going to be used on each of the nodes, and using these specific macros, and we extract this property, the information of this property from the DTC to start using in an actual C code. Okay, why this is important? Because all the information about the driver that you're going to use has to be extracted from the DTC, especially the one that means the hardware, because you are describing the hardware. A peripheral, a driver, it's meant to control a hardware. It could be internal from the same microcontroller or external, like a memory, like a display, like any kind of sensor. All right. So we should be able to declare the properties in here, like for instance, the UR baud rates, to give an example, a pins to control or to read an interim from the external sensor, whatever, you name it, resolution from the displays, blah, 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 blah. And we should be able to learn how to extract this information to starting using into our C code. All right. So we're going to end it like here. Okay. We're going to end with binding files up to here, because the next part of the of this webinar is going to be all about to start writing code to control our LEDs using this function as the low level drivers. And what we're gonna do in our next webinar is to starting to using more and more macros that is included in the Zephyr in order to extract the information that we write in each of our nodes. Okay, we're gonna let that for a second for the second part of the interview. We want to keep it short. We want to keep it clear. We want to keep it simple in order so it will be easy for you to go back, watch the video again, and see what's going on with the binding files. So it's up to you to start playing around with binding files, create as many binding files as you like, declare properties, and along, etc. Right? The DTC has its own syntax, and that's very important, right? Where you can find that information? Well, there's several ways. You have the Zephyr official documentations. You can find device tree bindings. I'm going to explain it really well about the device tree bindings, syntax, how you can declare For instance, the types. It's just telling you that you can use type of the properties could be a string, int, boolean, arrays, whatever. So my recommendation is for you to read these documentations, to play around declaring new properties, and using the same documentation. It's just starting right as simple programs where you can extract these properties from the DTC, playing with the different values until you feel comfortable with writing your own binding files. All right. So my name is Diego. This was the webinar for today. But before you leave, we had a surprise for you. All right, because today we are just initiate the. So this is our Zephyr online training. It's a training that we've been prepared for several months up to now. It will consist of 12 weeks, 24 sessions. It means 2 sessions per week. It will be available more than 120 examples just for you. Very easy examples to follow, so you can replicate, you can modify, and you name it. Okay, more than 80 exercise that you can use in order to reinforce what you're gonna learn on each sessions. You can go. This is the link. So we're gonna place the link under the description of this webinar. We're gonna make the announcements on LinkedIn, so be aware today. And this is the content. This is the course content. Okay, these are the complete weeks. So what you're gonna see during the training, what you're gonna learn. So you're gonna start from the very beginning. So for instance, if you're a person that just is starting working with Zephyr, this training is for you. If you have the intention to move from other operating systems like FreeRTOS, Nutex, ThreadX to Zephyr, then this training is for you. So you never worked before with real-time operating systems, but you had a previous experience working with embedded systems, then this training is for you. You want to speak about, you're going to learn about WES, you're going to learn about peripherals, the drivers like the serial communications, you're going to learn interrupts, how Zephyr interacts with interrupts, how to handle and how to manage the console, the login message, build fundamentals, how to structure a project, and how to build it using WES. We're gonna see a lot of the kernel. You're gonna to create your own threads. You're gonna understand how the operating system schedule the different threads that you declare, inter-thread communication, the different mechanisms that Zephyr has available to communicate between different threads and interrupts, synchronization mechanisms like mutex, semaphores, uh, work queues to defer executions, and things like advanced communications using C-Bus. This is a very, very good topic. This is uh, peripherals like ADCs, the sensor interface, that's something really important. Remember the Zephyr born in the industry of the IoT, where sensors are pretty much everywhere. And we want to speak about I2C. We want to speak about the new data structures called RTIO for the sensor interface. You're going to build your own device driver from scratch. Not only this example, but more advanced examples like a driver from a sensor, from a display, etc. You're going to have to create and define your own board, because most of the times on your projects, you are not going to use one of the commercial boards that you can find available, and that already comes with Zephyr. You're gonna have to create your own board, so it's necessary for you to understand how to create your own, how to define your own boards. And finally, we're gonna explore how the startup sequence, what's gonna happen since the vector reset to go to the first thread that is run. What's happening there? Okay, where the drivers are initialized, and etc. etc. And the last sessions will be dedicated on telling you how to contribute to the Zephyr projects, which is something really good. You can make contributions, small contributions like solving bugs, with documentations, with new drivers, etc., with new ideas, etc., etc. So go to the website of the trainings. All right, we have a very good special offer for early birds. and we're gonna have more. So we're gonna use actual hardware. You're not gonna use simulations, nothing like that. It's gonna be 90% of the trainings will be hands-on. So meaning that you're going to work with your favorite board. You're gonna flash your programs. You're gonna run your actual programs. You're gonna learn how to debug your applications using tools like Zephyr Ozones, JLinks, and System View to visualize the different thread executions. Right? Hope you like it. Going to start on night 11, so you're going to have time to ask questions about the Zephyr online training, and we would like to see you in there. Right?